let's do some examples of stuff that you're going to find in your homework. These are longer word problems. They'll also pop up on your next exam. And it's going to be challenging. There's a lot of algebra involved in this. This is really when we're going to get into algebra and test your knowledge. Or maybe you're just going to learn a little something right now, because we're all at different places. Some of us are waiting to take college algebra till after this class, so you might feel a little bit discouraged. Do your best. Follow along. I'll give you all the steps. I'll try and be as clear as possible. But don't get too beat up by this stuff. Try and follow along as best you can. And we can get through this. Because this is something, I'm not trying to make your life miserable. I know you're going to need to do this in a physics class later. If you're going to calculus, you'll need to do this as well. So I want us to become pros with it now. So this is the tough word problem type of thing. And we're going to break this into two parts. This is long. It's going to take me about 10-12 minutes to do 2 of the 4 parts. So we'll break it into 2. So we'll just do our first 2. Did I say 2 enough times? First 2 things? All right. Now here's our situation. I don't want to show you what the questions are yet. It's going to give a situation, and let's read through it. It says that Sam hits a golf ball with an initial velocity of 100 feet per second at an angle of 30 degrees. Okay. Well, let's gather the information from here. We have our 2 formulas. We're talking about parametrics, and we're talking about projectile motion. Let's see, what's this saying? Let's see if we can't define our variables. So it's talking about an initial velocity of 100 feet per second. Would you mind if I just kind of wrote down the initial velocity is equal to 100? Would that be cool? Could I do that? Just kind of remove the word problem and make it more of a just plug it in sort of problem. Now where's the other number? Oh, there it is. That's 30 degrees. And that says angle. Do you mind if I just say theta equals 30 degrees? So we got an angle, we got an initial velocity, but there's one more piece of information that's in here. I'll take you right over. I mean, these 2 formulas are what we got to use. We're talking about parametrics. Our initial velocity and the angle. Our initial velocity and the angle. Now time is just time. The only thing we're missing is h. What's h? You know, what's the initial height? Now it's not given in the problem, and nowhere does it say what the height is. But Sam hits a golf ball with an initial velocity of 100 feet per second at an angle of 30 degrees. We're going to assume that thing's on the ground. Know what I mean? Know what I mean? That the initial height would be equal to 0. Sometimes you'll see it like that, h naught, saying that the initial height. Now, a lot is assumed in this problem. We're thinking that homeboy's standing here and with his golf club, I can't, and going to hit the ball onto flat ground. All right, I know it doesn't say it, but we're going to assume that. So, all right, sorry about my horrible drawing. I guess I'll just leave my horrible drawing there. Let's go see what the questions are asking. So this is a 4-part problem. And in this video, we're going to do these 2, okay? We'll just knock out A and B, and we'll get to C and D in the next one. That way you don't have to watch a 20-25 minute video. And I don't accidentally hit stop again when I was about a minute away from being done and I throw my shit. But that's neither here nor there. Let's read the question, huh? So we want to find a parametric equation that describes the position of the ball as a function of time. That's a fancy frickin' term for take that crap that we just found and plug it into those parametric equations. Find a parametric equation that describes the position of the ball, whether it's horizontal position with x or its vertical position with y, as a function of time. That means those t's, right? Not always, but that's what we're going to want to do. So why don't we go run back over to those couple formulas we had, and let's start plugging this stuff in. And that's going to be our part A. That's all we're doing here. We just want to take these values we discerned from the word problem, and we just want to go get some values. We want to plug it in. So x is equal to 2 things being multiplied together times t, and both of them are numbers when we plug it in, right? V naught is equal to 100. times cosine of plug that angle in 30 degrees. Both of those things are just numbers. So x is equal to 100 times cosine of 30, I think that's root 3 over 2, times t, and we find out that this is just a simple line. 100 divided by 2 is not 50? That's 50, right? So 50 root 3 times t, or about 86.6, I think it is. I don't know. Some number times t. That's all it is. Cool. We did it. We found our x. Now, the more challenging one, of course, is to plug into y. There's more stuff. Okay. Well, y is equal to negative 16t squared. That's not going to change. Plus, oh, we're going to need to plug in for t plus our height. Okay, let's go. So our v naught is still equal to 100. Except instead of plugging into cosine, we're going to plug into sine. So we say sine of 30 degrees. And then we need to add that height. The initial height was 0, so we can ignore it. Cool. Let's clean it up and solve. And let's get it ready because we're going to need to use these in the next parts. So negative 16t squared plus, that's 100 times, what's sine of 30? I think that's a half. So y is equal to negative 16t squared. Half of 100 is 50. And bang, we did it. So if you're dealing with any sort of motion, projectile, talks about heights and that, and actually, these are the formulas you use. You want to clean them up, get them as nice and clean as possible. And I beg you, do not turn that into a frickin' decimal, because by the time you get done rounding on your next problems, it's not even going to be close, and Web of Science is not going to accept your answer. Or whatever tool we might be using in the future. Okay, there's part A. We did it. Yay, look at us go. Let's go to part B. So we handled this part A, done. Part B, let's go get it. How long is the ball in the air? So how long? So it's asking for time, right? So how long? If it's asking how long, so it's saying like, what's t? So the question's asking for t. Cool. But how could we figure out anything else? Like, how long is the ball in the air? Do you mean when the ball's on the ground? Like, wouldn't that be the end? Like, when it hits the ground? Like, you know what I mean? Like, here? Here, and like, if the ball was traveling like this, you know what I mean? When does it hit the ground? Well, what height would that be if we were on, like, an XY axis? Wouldn't that be where y equals 0? That would be where y equals 0. Oh, sweet. Because we're talking about height. It doesn't have anything to do with the horizontal component, or x. It has to do with the vertical component. Y equals 0, right? The ball hitting the ground. The only thing that's acting upon the ball is the force of gravity, because we're going to ignore wind resistance, centripetal force, and a lot of other things. We're just going to look at this thing and go, well, dude, to solve part B, we're talking about when's y equal to 0? When's the height equal to 0? So we have a formula already set up, not in that nonsense from up above. We can just set it equal, go through, and solve. Now this is going to be much simpler when there's no initial height. So you don't have to use the quadratic formula. We can just factor and solve. So if you don't mind, before I do it, I just want to take this function. Our y is equal to 16t squared plus 50t. And I just want to just give you a shitty little graph of it. Just kind of, it's a parabola that's facing down. But that's the t-axis, the way we're drawing it, right? Because it's y's and t's, not y's and x's for this one. So we're just talking about how long does it take for it to hit the ground when the height is equal to 0. All right, but aren't we going to get two different points? We're going to get an answer here. We're going to get an answer here. Now, if you were to graph this on a graphing utility, it would continue going down, right? Because math doesn't understand context. It doesn't understand that the ground is there. So we have to give it context. We only care about where those axes are. And I know that this is a parabola facing down by the fact that it has a negative in front and a square on top telling me it's a parabola facing down. Little key things like that you should be paying attention to. It's how, I don't need to know how to exactly graph that shit. I just know it's a parabola facing down by just key little pieces. All right, enough babbling on. Let's finish this sucker up by setting y equal to 0. So that negative 16t squared plus 50t. And let's go through and solve. So let's factor out, let's get two things. What's in common? There's a negative, I don't like that, so let's factor out a negative. There's a t in common, and they're both even. Let's say negative 2t. So that would become, I think that's going to be 8t, right? Because negative 16t squared divided by negative 2t is 8t. 50t divided by negative 2t is just going to be negative 25. And now we use the zero product principle to solve. All right, let's just set both of those pieces because we're multiplying them together. So we find out that t is equal to 0, and we go, oh, no shit. The ball was on the ground right as the person hit the ball. Math doesn't understand context. Math doesn't understand context of we don't care when the ball was hit. We know it was hit at time equals 0. Yep, and it was on the ground. We care about the other one. We want the one where it hits the frickin' ground. So let's solve. Let's move the 25 over to the other side, and let's divide by 8. So we get that t is equal to 25 over 8, and since it's a word problem, let's just write in seconds. We found out when the ball hits the ground. And if you're curious, that's approximately 3.125 seconds. So that tells us when we're going to hit. We come over here, we see that right there. When time is equal to 25 over 8. That's not x, that's t. Seconds, the ball hits the ground. All right, so we handled our first ones. We handled A and B. We're all done. We know when it hits the ground. We have two parametric equations. And then when we come back, we're going to look through and we're going to see what is the maximum height of the ball. And we're going to determine the horizontal distance of the ball. Now, this is really what we've been leading up to. This is the more challenging parts of the problem. So we'll be back in the next one to handle C and D. See you then.